Okie doke, friends. So I wanted to open up with a little example today, and then the rest of the time is going to be we're working on the web work as we discussed on Monday. Is anybody done with that web work? Because that was like good. Okay, I was like, damn, you've been busting it, because that's a hard web work. So good. Nobody's done with it. Excellent. That's what I'm hoping. So let me find freaking notebook. Got it nice. Seriously. Oh no. Oh no. All right. I hope to God I remember this example. Goal is to find a tangent line, but to something really odd that we're not used to looking at. All right, so I'm going to create an implicit function. So I want to talk about that a bit. No, I don't want that guy. That's a little intense. I want x squared times y plus 1 over x minus y. I want that to equal 2. No, that's not the cool one I had. I swear, man, I had something so cool. And that ain't it yet. Maybe it was x squared y. X y squared. Yeah, there he is. Okay, I remember. Okay, so check this out. Got a really fun, pretty cool graph up there. Not one you're used to seeing. So what I've got is this equation: xy squared plus 1 over x minus y equals 3. So this is an implicit equation. It's an implicit, it's a relationship between x and y. Once I know one of these guys, if I know what y is or I know what x is, I can find the other. It might be some work, might be a little bit of algebra, but I could do it. But it's not obvious at all. What are the points on this graph? So if I plot all the x and y pairs that satisfy that relationship, look what I've got here. Is this a function, by the way? No, that's not a function because it doesn't pass that vertical line test, right? So this is quite not a function. What are some things I should worry about here? What would be some bad things to happen with x and y? Yeah. So x and y should what should I say about x and y?
It shouldn't equal 0.
Yeah, x minus y should not equal 0. Everybody cool with that? I don't want a 0, and so x shouldn't equal. So we just make that restriction on there. We're not even doing the calculus yet. We're just kind of like, what the hell is this thing? This is pretty weird. And I just made this up the other night. When I saw the graph, I knew I had to share it with you. There's some neat things going on here. I want to show you some things. Notice how it's certainly got that vertical asymptote when x and y are both 0. That makes sense because you can't divide by 0, so you see that thing blowing up. But it's also got horizontal asymptotes. And we might wonder, what are those horizontal asymptotes? Are they even asymptotes that are non-zero, or does this thing kind of shrink all the way down to 0 eventually? Turns out it doesn't, but that took me some serious work to convince myself of. Well, what I actually want to do here is find a tangent line to the point at 2, 1. Notice how 2, 1 is actually beautifully on here. So if x equals 2 and y equals 1, this is satisfied. See, I've got 2 times 1 squared plus 1 over 2 minus 1, and notice that is 3. So that point is on the graph. And you can see it right here. It's one of the few places where it actually goes through a perfect grid point, 2, 1. We're going to find the tangent line here. the equation of the tangent line. That's our goal. Goal. Find equation of tangent line at 2, 1. Step 1, find the derivative. Because that's step 1, everything we do is find the derivative. So I need to find y prime. Step 1, find y prime. But damn, y prime is like nestled in there. That y and x are nestled deeply together. So what we're going to use is implicit differentiation. And we talked about this, but we didn't do a lot with it. So I thought I'd really kick us off with a hell of an example. Explain differentiation. So the way this works is I treat x and y as differentiable things, differentiable quantities. So I'm always going to take a derivative. If I see y squared, I'm going to make it 2y. If I see an x cubed, I'm going to make it 3x squared. I'm going to use all my derivative stuff on that. So when I take this derivative of this left-hand side, I've actually got x times y squared. I'm going to need the product rule to differentiate that guy right there. So what do I mean by this? View y as a function of x. So let me show you if I rewrote that up there. I might actually even write it like this. X times y of x squared plus 1 over 1 minus y of x equals 3. I'm imagining that some way I could possibly think of y as a thing that depends on x. And it does, because if I tell you what x is, you can find a y value. You might be able to find several, and you can see that that's true. But we can restrict ourselves and think, let's just worry about one of the values that's coming out. So I'm going to differentiate this thing right here. And every time I see y, I'm going to think y of x. So that means I have the chain rule. Notice this is a chain rule when I differentiate that, because it's a y of x inside of another thing. So let's do this. Let's differentiate. d dx. So first thing I need is the quotient rule, because I have quotient. That's the biggest pattern. Derivative of the top is going to be 1, so that's the derivative of the x, times the y squared left alone, plus the x left alone, so this is the product rule, times the derivative of y squared, which would be 2y to the first. Think about how you would do this. I'm going to write this here just for a second. If I asked you to find this, you would go, the 2y of x to the first, and then you take the derivative of the inside. So what we're going to do, that's y to the first there, not y prime, is every time I differentiate a y expression, I tack on a y prime as the derivative of the inside that I'm imagining. So that's the product rule on that, and then plus 0, the 1. So that's the derivative of the top, and then I've got bottom left alone. I'm going to show you an easier way to do this in just a minute, but we're going to do it this way to practice implicit stuff. Minus first part, or top left alone, times the derivative of the bottom. Derivative of x is 1. Derivative of y would be 1, and since I differentiated a y expression, I tack on a y prime. All over x minus y, quantity squared, and the right-hand side is just 0. Let me stop. Does that look okay? Are you laughing at the phrase "okay," Sophia? I thought I heard you laughing at this, like, okay. Okay, now, as long as x and y aren't equal to each other, this isn't 0 in the bottom, and I could multiply through by it. So I could multiply through by this denominator here, as long as it's not 0, and we already said it isn't, so yay. So multiply both sides by this. 0 times this is 0, so what I get on top is y squared plus 2xy prime, and that's all in parentheses, times x minus y minus this crud. It's not crud, it's really pretty. I shouldn't have called it crud. Y prime equals 0. I gotta solve for y prime in terms of everything else. So now solve for y prime. So you're gonna get y prime equals everything else on the other side. I wish I hadn't restricted myself to this. Now I gotta turn this, yes sir.
Why'd you get rid of the x minus y squared on the bottom?
I multiplied across by x minus y squared.
Oh, okay.
So I multiplied this side by that and then the right side by that, but 0 times that is just 0.
Okay.
Does that sound okay?
Mm-hmm.
And you can also think about this a different way. When is a fraction equal to 0? When the top is equal to 0. So in some ways you could think of this as just setting the top equal to 0. That's also equivalent. Does that sound okay?
Yeah.
Sam?
Repeat what you just did, sorry.
That's okay. So I've got a fraction
Yeah,
equal to 0. The only way that could happen is if the top is 0.
correct.
So here you could think of this as I'm just setting the numerator equal to 0.
Setting the numerator.
Yeah, so this part, so I've got this over this equals 0.
Okay,
So the only way that can happen is if
Is it-
just the top equals 0.
okay, I get that.
Okay. So what's the browse for? The look of consternation. What's troubling you? There's still more to do. Don't worry. I have.
Yeah,
Okay.
I
Okay.
understand that there's more to do, but like, just, I don't know, it's just not sitting right with me that you got rid of the x minus y. The bottom.
If I told you that I've got x minus y over x squared plus y squared equals 0.
Okay.
Take a look at this.
Okay.
Can the bottom make this thing true? Can this can equal 0,
Yeah,
but you can't divide by 0, right?
correct.
So what if I say, okay, x and y are not equal to 0. So the bottom's not 0.
Okay.
It's a number.
Okay.
How can this fraction equal 0 on the left? What has to happen for it to equal 0?
The numerator.
Yes. So I can forget about the bottom because the only way this could ever equal
okay.
0 is that.
Okay.
That's cool.
I got
Awesome.
that.
Good, that's good. I'm glad.
I was overthinking.
No, yeah, it's okay. It happens. Thanks for pushing through.
Yeah.
Yeah, it's all good. Any other questions on this? Nice. So now the hard work. That's not the hard part. Here's the hard part. Now we got to find y prime. It does sound fun. I agree. So let's do it. Don't do any division until the very last step. So the plan would be get all y prime stuff on the left, and then all other stuff on the right. Everything else on the right. Let me give you a minute to do that. Let you have some fun. I don't get all the fun. That's cool. Neat stuff does happen. Cool things are happening. Some cool stuff's gonna cancel. And save it for a prize for us all to look at. And if you see something wrong that I'm doing or it doesn't make sense, please call me on it. Notice how I got all the y prime stuff on the left? The next move would be to factor that y prime out of everything you put on the left. And I'm gonna actually distribute this all out, so it's 2x squared y minus 2xy squared plus xy squared plus 1. There's some cancellation that'll happen there. And then this side, this is pretty, because this is minus y squared x plus y squared x, so this cancels. And I'm left with 1 plus y cubed, I think. Does that sound, yeah, we're getting, let's stop. Let's make sure we're feeling good about the algebra. Because this is where this can go wrong. Would it be okay if I erase the bottom? Yeah. Okay, on here otherwise, so I'm doing it. And I'm just about to step. I'm going to actually simplify this expression a little bit because that is just minus xy squared. So it's 2x squared y minus xy squared plus 1. Y prime equals 1 plus y cubed. And then lastly, y prime equals 1 plus y cubed over this critter. And I know it's ugly, but we don't worry about that. We just go with what the symbols tell us. Did anybody get the same derivative? Because I kind of want to have some democratic sanity checks going on in this house. Zeus, did you get that? Something close to it.
I mean, it looks right.
Okay, yeah, okay. I think that's what everybody's kind of thinking. But don't believe me. Trust yourself, too. This was the hard part. Like, we're almost, we just have to make sure. See Addie checking me out hard course. This is good. Thank you. If we could pull up like Wolfram Alpha and have it do it for us, that would do it. I guess we could, but I'm just gonna believe in myself. If this is right, and if somewhere along the lines Addie figures out that I fucked this up, she'll let me know. But let's pretend it's right, because it doesn't matter. It's like a point off. If it's wrong, it's okay, because I just wanted to show you the basic idea. I might have screwed up possibly a little bit algebra. I don't think I did. And so this guy here, we are going to evaluate to get the slope. So this was step 1, right? Get the derivative. Step 2 is evaluate the derivative at our point. And our point was x equals 2, y equals 1, so y prime is going to be our slope, so I'm going to write m equals y prime equals, now I just plug in 1 for y, so I get a 2 on top, and in the bottom, let's see, what are we going to get? 8 minus 2, 6, 7, 2 sevens. Yep, that's what I got at home, so that is right. If that's a way to check rightness. I got 2 sevens last night when I was working this out. So that's our slope, and it looks reasonable-ish. If we look at our point, that slope is less than a half, and that's a very shallow slope right there, so I think we got it. That's the hard part. 3 is use y equals m times x minus x naught plus y naught. You all know how to do this. Everybody rock this on the exam. Y equals x minus 2 plus 1. There we go. You have a number of those to do yourself. I want to show you a quicker way that I could have done this really fast. Let me kill this off. There would have been a good move I could have made at the beginning. That this is the one I made at home, so it's kind of cool that I got to see it. Son of a gun. You good? You stop. All right, you're done. Here's what we could have done at the very start of the equation. Remember, we had xy squared plus 1 over x minus y equals 3. I could have just multiplied the fraction away at the beginning. So I'm going to multiply both sides by x minus y, and I get xy squared plus 1 equals 3x minus 3y. Oh my God, no quotient rule. Hell yes. That is so good, because that quotient was not fun. It made Sam really upset. He didn't like it. So now it's gone. We don't have to worry about it anymore. Can you do me a favor and differentiate this implicitly? Can you find y prime from that version, please? Just to check yourself. Need the product rule, right? You got the x times y squared. This for the x y squared, this is what you need to do. Don't forget that y prime when you differentiate anything y primey. And the right side is just 3 minus 3 times 1 y prime. You don't need to write the times 1. I'm just putting it there for our today. And when you stop that, now it's a lot easier. You're moving all the y prime stuff to one side. Is a big relief compared to what we had before. Then I got a dilemma I need to figure out. Let's see. Did I do this all right? Looks like it's such a different looking answer. That's the part I'm going to try to figure out what the hell is going on with that. Must be some kind of factoring we can do over there or something to turn these two into each other. Right now, I'm not quite sure what that's going to be. So we get y prime 3 minus y squared over 2xy plus 3. Did anybody else get that? Yes, Joshua, you got it. Leo, you got it. Okay, and Kyla, awesome. Okay, that's pretty much good enough for me. That you, the three of you got it. Let's make sure we can all get there. And then I get to have the fun problem of figuring out what is going on with these guys. That looks really fun. We gotta make sure, let's make sure the slope is the same as well, because now I'm kind of wondering, do we get the same slope out of this? At x equals 2, y equals 1, I don't think we're not getting the same slope. This is something, what's up?
The same.
It is the same. Oh, okay. Oh, it's just 3/7. That's right. I was thinking 7. So verse 17 came into my head. So yeah, awesome. So here's a little cool notation. Y prime, if you put a vertical line, this means evaluated at. Evaluated at. And then you put x equals 2, y equals 1 down here. And it's just a good communicative device. And Joshua said it's 2/7, so it sounds good enough for me. The rest is the same. Feel good about this? Cool. So that's all I got for you today. I definitely want to leave this time for you to work on the current web work, because it's going to take some work. And we can, let's see, I don't know how many problems are on it? 10?
Yeah, 10.
Wow, what a bastard. Man, oh man, that guy's a chump. Yeah, evil, unbelievable. The professor is such a chump. If you don't have your web work, don't feel.
Oh yeah.
Yeah.
So this is me brainstorming. So why is what I do?
Oh,
Just like.
yeah. You just didn't give me. It says find f prime. You just didn't write it out explicitly, but it was clear that you knew what to do because you plugged 64 into it. It's because f prime of x is 1/3, 1 over 3x to the 2/3, and that's exactly what you got here.
Is it right?
You just didn't. Where is f prime in that line?
I know. I'm looking. I'm like, no, I completely overlooked it.
So yeah, but I saw that somewhere you had it.
Yeah. No. Okay.
So I figured, okay. I mean, here it is with a 64 instead of an x. So I was like, okay, he knows what's up. So
No, that makes sense.
is that good?
Yeah.
Yeah. That's why I wrote. Clearly, you know this. So
That's
yeah.
funny. Well, that's nice to know you're a generous teacher when it comes to like my AP calc. She was like super lenient, but she was also like there's teachers out there who like they want it exactly 1-to-1, perfect syntax. You do one wrong thing, it's like no. My other teacher was like, I'll at least give you half of the credit if you do it right. If you just have one wrong syntax.
I mean, I feel like you can still learn without losing points, right? You know? Yeah. Like sometimes I will like take off like a tweak just to like make people look at it.
Sure.
But you looked at it, so I didn't even need to do that. So it worked out great, all around. But yeah, there is a web workup. I don't know if you knew that or not.
I didn't see that.
Okay. Oh, that's
I
okay.
just
This.
Yeah, you told me it was fine.
Yeah, we are fine on that. Okay. Probably have another one next week.
What?
Another quiz, yeah. I mean, we need to have more than like one. It's kind of like, it's like 20% of your grade. I think it should be more than one thing.
Yeah.
Yeah, so we'll have a few more of those. But, yeah, you do as you see fit.
I don't have my laptop.
You could actually access it through your phone. I'm not like saying you have to, but I occasionally do, just to look at the problems.
Sure.
You do use this.
I appreciate you. Wait, does that mean if I want to leave, it's okay?
Yes,
Okay.
yes.
Cool.
I'm not gonna let you walk out and then go, I can't fucking believe you just left. And if you need help, that's what today is for. You let me know and I'll come and do what I can to help you.
I do have one question.
Yes.
I never did the exam review on Upwork. Is that like, is there still like a grade for that?
If
I know it's
that was-
open, but it's
there-
just review.
The deal was if you did 15 of them, you could get a 10-point buffer on the exam.
Oh,
Kind of, you didn't need it.
okay. Yeah, it's,
So you're good to go.
I didn't realize it was there until after the exam.
Oh, okay.
So-
Yeah, yeah. That's good. All right.
Thank
I'll
you.
see you.
Have a good one.
Bye. You too. Probably gonna turn the recording off. This is kind of boring for YouTube. Even for a math channel, this is pretty boring. Bye, folks.